But there is other we call toy model. Duffing equation. Linear free vibration system is everybody knows this, right? Even equation. This is K is a spring, C is dashboard, M is mass. That's the gravity. Then equation is written by this way, right? M acceleration, K, X is difference, C is the velocity of the difference. Is it okay?
Okay.
Right? And angular frequency and frequency. This is the freshman's lecture. But the X, this one is here. The forces came from the spring is a linear, proportional linear function. K is a constant. But therefore the relationship X and K is this. No, this is Kx, sorry. There's no stochastic terms. All terms are deterministic. However, it showed this type. Now, this is the Poincaré section, is that to slice every period, then project the point on that. This is Weathers-Duffing's equations, and by changing the parameter 1% and red and blue, and shows a quite big difference. This is a phase portrait, and X and red, blue and red as a 1% difference of initial conditions. Yeah, that's a thing. Okay, this is the JP attractor version 1. Is these equations. You can make this type of the strange plot, and you can run my program.
Okay.
This is a Vanderpool. Vanderpool model is here. By changing the parameter, Fitz-Nagmo. This is Fitz-Hogg-Nagmo model is a very popular model for the nervous system, nerving system, and neuron system. Probably you may easy to understand the this simple.
Yes.
Right?
Yes. Yes.
You can go Nagmo circuit. That's the Hastings-Powell. I showed this slide in the first lecture. Okay, this is probably you remember. This is a kind of the logistic. If x reaches to the 1, this term becomes 0.
Yes.
Okay, this is plankton's population increasing. This is X is plankton, Y is from fish, Z is the big fish. Plankton is eaten by small fish, is this red term. Then, and because of the small fish eat the plankton, it's increasing. But this small fish eaten by big fish. This is a mortality rate. Then this is a very simple food chain, 3 species food chain dynamics, and Hastings, Thomas Powell, and this is my. Now we are writing the paper scheme, but yeah, and in the XYZ plot, and they show the quite unique, and the blue this time is the same, and the blue and the red is the initial condition. This is slightly different. This is the same thing. Okay, chemical reaction, A and B add the reactant, and DE as the product, and then also upload the program. And this one is photoprecisionogram, and this is commonly used. And dead and photo detector, this LED, and this photo detector change the volume of the blood. This is the output of the blood. You can see. We call PPG. This is time and PPG. That is population cycle caused by the over compensating density plot. It made it very simple, and this blue plot is experimentally obtained. These point. This is the actual data, and this is the population seed production per square meters. Seed production per square meters. If the population is very small, there is no competition among the individual plants. They grown up well. They produce large amount of the seed set on each individual plant. But the number of the plant is small. Therefore, the total seed production per square meter is small. But here, it's a number of the seed plant is so much, very crowded. Therefore, each individual plant cannot grow up well. Therefore, the only small number of the seed set for each plant. Therefore, the total number of the seed production is very small. Therefore, in this area, and it's not so much crowded. Therefore, they grown up so-so. Then total amount of the seed production is high. This is the type of the annual. Then the thing that happen is germination rate is here. Compare with germination rate, meaning this case is germination rate is the definition is autumn you produce this amount of the seed, and after the winter, in the spring, some small amount of seedling came up. This is germination rate is this time 0.2. Germination rate is 5 times larger than that. Is 1% is this. Therefore, you can show this type of the graph. We call cobweb graph, like this. And the germination rate is small. It's saturated. Germination rate is large. This data is actual. This is just the models. But the thing I'd like to tell you is, in agriculture, food production, population density is very important to determine how many seeds should be spread on the field. Too much is bad. Too small is bad. Then sometime, and even in the annual species, show that this type of the fluctuation might be possible. Therefore, the completely concept is same as the deterministic. Okay, deterministic chaos is two important features I already explained. Sensitivity dependency on initial condition. In density dependency on initial condition, in other words, it means short-term predictability. Short-term is predictability possible, but long-term unpredictability.